Hey, good morning, everybody. This is Mr. Ainsworth here, and we're going to do a full-on review in the form of a mind map, though. Probably the first time you've ever seen this because not too many people teach mind maps, which is a concept map, basically downloading everything you know about a certain topic. In this case, linear functions. All right, so there's nothing new in this mind map here or this concept map, but it is a full review of everything you learned in the past couple months and all the concepts that you need to be really good at. Okay, so the first thing you need to do is go to Canvas. All right, so go to Canvas here, refresh your Canvas obviously by swiping down, and on your Canvas app, go into Unit 2 here, go at the bottom of Unit 2 where it says MM1 for mind map. All right, linear function mind map. Open that up right here, and then put a copy into OneNote. You guys know how to do that. So when you're on OneNote, though, I want you to do something. So check this out. Notice that I have 4 copies of the document right here, and you guys know how to do this. All right. So what you do is once you print it out right here, you click on the page here, click on text box. There should be a T in the upper left-hand corner of your iPad here in OneNote, and you click on it, and guess what? The copy command comes up here, and you select copy, obviously. And then when you select copy, you have the ability to copy it. So you press and hold on the outside of your document, paste comes up, and you simply paste it in, and you can put as many copies as you want in here. I already have 4 because what I want you to do is go through this video with me, obviously, watching and taking very, very detailed notes, okay? Give it your best, all right? And make sure you have full annotations on this as I go through it. And then over each day for the next 3 days, you're going to try to go through this on your own without me, without looking at your notes, okay? Can you actively recall everything on your own? That's the test. Okay, so since you're probably watching this on Friday in class because I'm gone, all right, label this Saturday because this one here is obviously Friday, right? Because you're watching this virtually with me. So this is in class right here. This is your first, obviously, lesson here. I'm going to go through it all. That's Friday. And then tomorrow you do it on your own, Saturday, and then write down attempt number 1, write down the start time, end time, so you time yourself, and then whatever the total time is, write it down. And then you're going to find out 2 things when you do this. You're going to find out what you know and what you don't know. All right, and obviously put it in a different color. Don't use red throughout this document, okay, because I have red and black here. You fill the document in maybe purple or blue or something like that, and then you make corrections in a different color. So you find out those 2 things. What do you know really well, and what do you don't know? And you find that only when you practice. Now, what's going to happen over time when you do this is like when you go to Sunday, this is Sunday now, the third copy here, you should be better. You're striving for 100% completion, so that's the goal. We're going to write that up here. So the goal is 100% accuracy. All right. And I think you probably should be able to do this in like, I don't know, less than or equal to 15 minutes maybe. All right, by yourself if you really know what you're doing. For my stronger students, probably less than or equal to 10 minutes. Okay, less than or equal to 10 minutes. If you can do that, you're pretty good. All right. Then you're the bomb. Okay. And then you do for the 4th time, that's on Monday right through here. And again, same goal, but you should get better and you should get faster. Okay? So notice that we have all these copies right here. And if you want to do it again later before the final, that's another good thing to do, right? All right, because you got to review. So let's get right into it. Here we go. This is everything you've learned. Well, not everything, but probably about 80% of what you learned in the last 4 to 6 weeks. So let's start off with linear functions. So let's start off with the slope. And this is when I first introduced the topic. Okay, so let's get started here. And we know the slope is the rate of change. ROC is rate of change. This little acronym right there, rate, okay, of change, ROC. And so what we want to do is figure that out. So given a table of values here is easy. So let's figure out delta x, your change in x here. And so from 0 to 3 is obviously plus 3. From 3 to 6 is another plus 3. It's increasing, so we're adding 3 each time. And notice it's constant, so delta x is equal to 3. Okay? Delta x stands for change in x. Okay, so change in x here. That's what delta x stands for. Now, what is the change in y? Well, we're increasing from 2 to 6, and that's simply adding 4. From 6 to 10 is an increase of 4. From 10 to 14 is an increase of 4. From 14 to 18, that's also an increase of 4. So delta y is your change in y, and that's constant. That's 4 as well. And then what you guys have to know is that the rate of change is also always delta y divided by delta x. In this case, it's 4 divided by 3, so 4/3. Okay, and that is your slope of the line of the, if you drew a line through these points. Okay, because we're talking about a linear function here, or points that line up on a line. Okay, so the rate of change there is constant. So the slope is constant, the rate of change is constant. So let's write that down. So the slope, which is the rate of change, all right, is constant. It's not changing. All right, and that's why it's 4/3. That's important. Now, as a function here, let's plot it. So follow the arrows here. So notice this mind map here that I've created here shows the flow of thought. Okay, so you want to follow the arrows. And so notice that I said plot the points, right? So let's plot the points. So 0, 2 is simply up 2. 3, 6, we right 3 up. Well, you know what? I don't know what happened here. My grid didn't show up when I copied this here, so we're going to have to estimate here. So put in the grid marks there. Okay, so 3, 6 would be right 3 up 6. Going to have to estimate right through here. And then 6, 10, so right 6 up 10. Okay, doing the best I can. Unfortunately, it doesn't copy the grid in my master notes. Okay, so my teacher notes, and then 9, 14, so right 9 up 14, right about up here. Okay, so now let's draw the line. Whoa, okay, that's too thick. Okay, so that's no good. So let's fix this here. Okay, so there's your linear function right there. So notice the points line up on a line, and that's why it's a linear, and that's why the slope's constant. Let's talk about slope here. So notice that the rise, okay, delta y is a rise, and delta x is called a run here. So we go up 4, okay, so go up 4. So grab your red pen, up 4, right 3, okay, up 4, right 3. Now, when you're taking notes, take detailed notes so that you know what's going on. Up 4, right 3. So so we know that the rate of change here, rate of change equals slope, which equals rise over run. As you guys know, I'm not talking anything new right here. So that's equal to 4/3, as you guys know. And that means that we can figure out what the slope-intercept form is of the line going through these points, okay? Because we know what the y-intercept is here. Y-intercept is the beginning point of a real-life situation. And again, we're going to talk about application here in a minute. Notice it's part of the mind map right through here. We'll get to that in a little bit. All right, but we're going over all the basics first, okay? So we know the y-intercept, all right, b is 2. We know the slope or the rate of change is 4/3. Okay, we know slope-intercept form. We know that's y equals m times x plus b. Okay, we also know that since the slope is the rate of change, I can write like this: rate of change times whatever x is plus b, which is this some beginning point. Okay, so I know that. So beginning point. So in this case, the equation that describes this line here running through these points is 4/3 times x plus the y-intercept there of 2. Okay, and there's the slope-intercept form of the equation. All right, so that's basically our first lesson when we started linear functions a long time ago, probably about a month and a half ago. And again, I'm just reviewing things here. Now, before we get to the latest concept we've been talking about, function notation, let's slide over here, and because we've talked about this extensively here, and let's talk about definition of slope and point slope form for a minute. Okay, so here we go. So let's talk about the definition of slope first. So let's put this in red right through here. So we have the change in x here, change in x, excuse me, change in y. What do I say? Change in y. All right, divided by change in x. Okay, I'm getting a little ahead of myself here. So what is that? Well, that's symbolized by delta y divided by delta x. Okay, I'm just going over some basics here that we've been covering over the last month and a half. And what is that? Well, that's nothing more than the rise divided by the run on the graph. And how do you calculate that algebraically? Because we're going to have to do it right now. Well, you take the y coordinates and subtract them. We call that y2 minus y1 divided by x2 minus x1. All right. You subtract the y coordinates, and then you subtract the x coordinates. That's the same thing as a change in y. And you find the change in y by subtracting. You find the change in x by subtracting. Same thing. And that's why if you're given 2 points, I just said subtract up here. Why? Because you got to take your x coordinates, the second one minus the first one, and then you have to take your y coordinates, the second one minus the first one. So write down subtract up. That's the easiest way to do it. So let's calculate it here. All right, so I'm going to take the second y coordinate, which is 6. I'm going to subtract the first y coordinate, which is -2. And notice that I put that -2 in parentheses. It's not 6 minus 2. It's 6 minus a -2. So be very careful right there. Go slow. Divided by the change in x, which is 4 minus 1. All right, so always start with the y coordinates. And I'm talking about this right here in the numerator. Always start with the y coordinates. Okay, well, if you're watching this video here, if you're working ahead a little bit, that's great. That means you're actually understanding what you're doing and you learned something. So, but make sure that you check your work as we go. Now, 6 minus -2 is 8. 4 minus 1 is obviously 3, so the slope is 8/3. There we go. And that's your first basic skill when it comes to linear functions, finding slope. Now, the second basic skill is using point-slope form. There are two basic classic problems. The first one here, we're going to do over here, and then the second classic problem we'll do on the right. So, given a point and a slope, how do you find the equation of the line? So let's talk about that here. All right. So point-slope form is y minus y1 is equal to m, which is your slope, times x minus x1, where x1 and y1 here represent the point that you're working with. All right. So given a point, 3, 2, where the first x coordinate, x1 is 3, the y coordinate, y1 is 2, all right, and you're given a slope of 4, which means m equals 4, obviously. Remember, monter, okay? This comes from French. Monter, which means to climb, okay, in French, okay? And that's why they use that word, is because hills have slope. And if it's not a hill, it doesn't have slope, right? Okay. So that's why they French, who came up with that variable right there, use m for slope and not s. All right. If the English, decided to come up with that term, then it would have been s for slope, which wouldn't have been good because, s looks like a 5. So thank God the French figured this out first. But anyways, here we go. So we're going to find the equation of the line here. So we take y minus the y coordinate. Now look at the point. The y coordinate's 2. The slope is 4 times x minus the x coordinate, which is 3. So now distribute. So we have y minus 2 is equal to 4 times x minus 4 times 3, which is 12. You got to distribute, okay? Distribute twice. Let's write that out. So distribute twice. Okay. So now we have to add 2, okay, and you get y is equal to 4x. 2 minus 12 is a -8, okay? Or a -12 plus 2, excuse me, why did I say -8? Come on, Ainsworth, -10. Silly boy. Okay, so, come on, fix that. Come on, it's late, it's getting late. So 2 minus 12 is -10 or -10. Or you can say -12 plus 2 is -10. 2 minus 12 is -10, however you want to think about it, guys. Okay, now the other basic skill is when you're given 2 points. So you're not given a slope and a point, but you're given 2 points. So now you got to find the slope first. Okay, so let's do that. So you got to subtract up again. So subtract up. So let's do it. So starting with y coordinates now. Okay, 9 minus 5. 9 minus 5 divided by 1 minus 3. Sounds like 4 divided by negative 2, which is negative 2. So my slope is negative 2. I don't know why my iPad's slowing up right now. Okay, so now you pick a point. Now it doesn't matter which point you pick. All right, so you have to pick either point. So pick either point here. You don't have to, it doesn't have to be A all the time. You can pick A or B. It really doesn't matter. We talked about that in class. So we take y minus 9, starting with a y coordinate. Again, this is x1 comma y1 here, is equal to the slope, which we found to be negative 2, times x minus the x coordinate. And look at point B, the x coordinate is 1. So you have y minus 9 is equal to, and then here we go again, you got to distribute twice. So distribute, distribute. Okay, distribute twice. So negative 2 times x is negative 2x. Negative 2 times negative 1 is a positive 2 because it's a double negative right there. Add the opposite, and you get y is equal to negative 2x plus 11. All right, so there we go. So again, the reason why I say practice, I'm going to go to how important it is to practice here, is because watching a video with me, you know, when you're dealing with something like this, that's one thing. But can you reproduce this on your own? And that's the whole reason why you're printing off 4 copies here in the same file, or you can do different files if you want. It doesn't matter. You can do that too as well. However, this is a cool way to do it. And what happens is when you practice, you find out if you really understand the material. And if you really understand it, well, guess what? You can produce it. If you can't actively recall this and you can't do what I'm doing right here, that means you really don't know it. And if you can't teach it to your buddy right next to you, yeah, I'm talking about the classmate right next to you, well, then you really don't know it, okay? So you want to get to the point where you can do it on your own and you can teach your classmate. All right, it's called the Feynman technique, okay, if you want to know. That's what it's called in the learning world. Okay, now before we get to the function notation here, we're going to save that for last. Let's talk about the application, okay? And we solved this problem before. This is a similar problem, but we saw something like this before, where we get to apply what we know about linear functions. So this is a cool one. So here we go. Suppose the 8-minute call cost $8.95 overseas. And if you call, like, say, someone in Europe or so. And a 12-minute call costs $14.55 overseas. And it's supposed to be overseas there. Correct that. Find the rate of change in dollars per minute. Right? Find the function relating the cost of the call to the time. Okay. So let's organize the information first. So first of all, an 8-minute call costs $8.95. You know, that sounds like an order pair to me. So 8 minutes here costs $8.95. Okay, so we got time and then minutes. So this is your x value, this is your y value. And then the next thing we know that a 12-minute call cost $14.55. And again, this is an x value, this is a y value. So what you do is you organize your information first, and then you can, you know, obviously do all your basic skills, right? Which we just talked about up here. Okay, so notice that we have 2 points. So it's kind of like example number 2 that I just did. We're going to find the slope or the rate of change, and then we're going to use points of form. So it's just like example 2 in the upper right-hand corner of the screen. All right, so now what we're going to do is we're going to subtract up. And guess what? We're going to use a calculator just to make it a little easier for you. So bring over Desmos. We've done this in class 2, right through here. And get ready to go. All right, so notice that I have Desmos on the right and my problem on the left. So do the same thing on your little iPads, okay? You guys know how to do this because we do it in class. All right, so now the rate of change is, you take the y coordinates, 14.55, subtract $8.95, divide that by 12 minus 8. Okay, well, if you can't do it in your head, that's okay. Type it in, 14.55 minus 8.95. Do what I'm doing, and that's $5.60. 12 minus 8 is 4. Then you take $5.60 divided by 4, and you get $1.40. Okay, notice I said $1.40 per minute. That's your rate of change. Okay, we're talking cost over minutes, cost per minute, cost per minute. That's your rate of change. Okay, so now what we want to do is we want to find the function, right? So we do that the same way we always do. We pick a point. So it doesn't matter which point you pick. So how about we pick this one here, all right, and we use it. So I'm going to write that down over here. So I have 8 comma 895. Again, this is my x1, this is my y1. And again, you could choose either point. Okay, so notice that I picked that point right there. You can pick either point, it doesn't matter. Okay, we've talked about that in class many times. So now let's find the function. So here we go. So y minus the y coordinate, 895, equals slope, which is $1.40, times x minus the x coordinate, which is 8. Okay, now we can't do anything on the left-hand side yet, but I got to distribute, as I keep saying in this lesson, twice. Okay, so now I take $1.40 times x minus whatever $1.40 times 8 is. So you type it in, okay, you get $11.20. Okay, add the opposite. All right, and so what do we get? So you type in 895, right? Oops. Let's try that again. So $8.95 minus 11.20. Or if you wanted to, you can type in a minus 11.20 and then add 895. I mean, look at that. You get the same answer, negative 225. Okay, so however you want to do it. So you get $1.40 times x minus $2.25. So remember, this is time and this is cost. So just keep that in mind. You know what your variables represent. Okay, so now what we want to do is find the cost for a 30-minute call. And again, x is time. So here, x is 30 minutes. So if x is 30 minutes, what's the cost? Well, we take $1.40 times 30 minutes and then subtract 225. So you type that in. So take $1.40 times 30 minutes and then subtract $2.25. And you get a cost, all right, so put a dollar sign on that, $39.75 for that 30-minute call. Look at that. All right, and again, this is what we're reviewing here, guys. We actually solved this problem a couple weeks ago. Now, let's talk function notation for a minute here. All right, so let's scoot this off to the side. All right, now the cost function in terms of function notation. See, so cost, let's call it C of x. Okay, everybody say C of x. All right, C of x, that's how you say it. All right, so I'm going to write down C of x is equal to $1.40 times whatever x is minus 225. There's our cost function. So I could have written this as C of 30, right? C of 30 is equal to $39.75. All right, there we go. So we're almost there, almost there. So now what we need to do is talk about function notation. All right, so let's go over here and talk function notation for a moment. Now, I said before that y equals f of x. So y equals fx is just a notation. This is not f times x. You know, a lot of beginning students in Algebra 1 think, oh, they see parentheses here, and it means x times x. That is not the case. This is not f times x. This is just a symbol, okay, which tells you what to do with the function. Okay, so I'm going to rewrite y instead of y. I'm going to write down f of x is equal to negative 2x plus 5. So these are the same. Y is the same thing as f of x. It's a y value. So what we're going to do is we're going to put a number into the function. Okay, in this case, x is 2. It's called the input. right? And we're going to get something out called the output. So we're going to substitute this in. So f of negative 2 means I got to take negative 2 times whatever x is and then add 5. Again, we have to substitute in for x. And we practice this multiple days in class, and so I'm just reviewing it. So x here is negative 2 right here, and so I'm going to substitute it in. Okay, I just substitute. So what is that? Well, negative 2 times negative 2 is 4, and then I have to add 5, and I get 9. Okay, so you multiply first, then add, as you guys know. Now, when x is 6, I take negative 2 times 6, and then I add 5. Well, you always multiply first, as you guys know, so negative 2 times 6 is negative 12. When you add 5, you get negative 7. When x is negative 7, you get negative 2 times negative 7 plus 5. You always multiply first, so we get 14 here plus 5, you get a total of 19. And that is just a little review of function notation, which we studied. If you look back at your previous lessons, I think it was 215 or whatever in Unit 2, that's labeled function notation. You guys can go and review that. Okay, last thing, given a graph, evaluate these things right through here. So, see, what's f of 0? Well, remember, this is the same thing as a y value. This is a function value. So when x is 0, what's y? So what you do is you go to the graph here, and you find x equals 0 on the x-axis here, and you go and read the y value. So when x is 0, y is 1. Why? Because it's always x comma y. On any point on the graph, it's always the x-coordinate and then the y-coordinate. So when x is 0, y is 1. When x is 2, well, you got to go up to the graph at point B, and you have to look at the y value, which happens to be 4, okay, which is a y value. So it's at point B here. Okay? When x is 4, whoa, what happened to C? C's missing right here. So label that C right there. You go up to the graph. So visually go up and look left. And hey, the y value is 5. So when x is 4, y is 5. So C is 4, 5, guys. If I ask you what f of 5 is, I said, hey, find the y value when x is 5. Well, 5 is right here. So label 5, go up to the graph, no, and then look left. Ooh, and y is 5 again. Why? Because it's horizontal right there. Okay, it's the same height. Now when x is 6 here, you're trying to find f of 6, you go up to the graph, look at it, look left, okay, and guess what? It's 5 again. Holy cow, so y is 5 again. Why? Because it's constant right there. It's horizontal. Okay, it doesn't change. Now when x is 10, that might change. I don't know. So when you find x is 10, you go up to the graph. At point E, you look left. Actually, let me draw arrows. This is the thought process right here. Okay, and look at that. Y is equal to 2. So y is 2. So this function notation is they're just y values, okay? F of x is a y value. That's why I said in the very beginning right here, it's just a symbol for a y value that you just have to get used to because we use it in higher mathematics all the time. Okay, and there we go. There's your entire mind map here, and the only thing you need to do is get good at it, and the way you get good at it is through proper practice, okay? And so what you need to do, one time each day, and it doesn't matter what time of day you do it, is practice. So the next one here is going to be tomorrow on Saturday, and you're going to record your start time, end time, total time, and you're going to make corrections in a different color to find out two things. You want to find out what you know and what you don't know, okay? You need to find what you know and what you don't know. And the only way to figure that out is by active recall. Okay, can you recall all of this? Can you produce all of this? It's called active recall in the learning world. Okay, and so you're going to do that on Saturday, and then you're going to practice 4 times. You're going to do another one on Sunday, then another one on Monday, and then you're going to submit this thing, and I should see progress over time. I don't care how many mistakes you make. I care about whether you improve. So we're looking for improvement. Okay? We're looking for improvement over time. So once again, I'm going to say this again because people don't understand this. I don't care about mistakes. I care about improvement. And I care about speed. So improvement, your accuracy should get better, your recall should get better over time as long as you practice, and your speed should improve. Everything should improve over time as long as you practice. All right. If you don't expect to improve, and don't expect to get good. You actually have to actively recall and space it out over time. That's called spaced repetition in order to get better. Okay. So make yourself proud, and I will see you in class. You guys take care. Bye bye.